Hello everyone, my name is Sing Yum and I worked with Eric Snow and James Tag. Our goal was to use optimization to help picking a new team for Fantasy Premier League for someone who's just joining this week. We picked this project because we all had a common interest in playing and watching soccer. To give more background on how Fantasy Premier League works, just like any fantasy football or fantasy basketball, users pick soccer players from English Premier League and get weekly points according to how well players performed. First, when a player joins Fantasy Premier League, a user is given £100 to pick 15 players, specifically 11 starters with 4 in bench. We also have to follow additional rules on the limit of numbers of players for each team and position. We can have no more than 3 players from the same team. Each player's points are calculated by their performances, like goals and yellow cards. You win in Fantasy Premier League by acquiring more points than other players that you choose to be in the same league with, or every player in the world. This is James's fantasy team, and this team has 15 players with 2 goalies, 5 defenders, 5 midfielders, and 3 forwards.
We optimized our Premier League results by using mixed integer linear programming to select the 15 players that would give us the highest score. Our decision variable was an array of in-Boolean variables such that 1 represents the player being chosen and 0 represents the player not being selected. Our objective function, then, was the sum of the expected points for each player on our team. You can see how we formulated our problem in Python. The objective function is the array of Boolean variables multiplied by the expected points for each player. We had several constraints to keep track of in a program. First, we must choose exactly 15 players. Second, we must only spend a maximum of £100 in a given week. In our formulation, we multiplied everything by 10. So we coded this by multiplying the array of booleans by the current cost of each player and ensuring this result is less than or equal to 1,000. Last, we had to ensure that we chose a maximum of 3 players from each Premier League team, which was easy enough to formulate in Python. Garobi found an optimal solution of 91.4 points for the current week's data. In our solution, we spent exactly £99.9. However, this point total included all 15 players on our roster, not just the 11 starters, so we recalculated our point total to get 70.8 points.
After obtaining the optimal selection of 15 players, we will now narrow down this group to 11 starters with the most optimal point total. This grouping of players shown here gives us a total of 70.8 points, which is less than the total of 91.4 shown on the last slide. This drop of points, however, is due to how we set up the model, as the 4 substitutes are still expected to get points as well. Each player in this model does have a non-zero chance of playing, but this still does not guarantee that they will play due to either their squad rotation or getting a last-minute injury right before the game starts. Having high-scoring substitutes who will be drafted in case a starter is not playing, will allow us to have a high points total as well. Looking back at our analysis, our cost is as close to spending our entire budget as possible without doing so, which is ideal for optimizing the budget. Since we have used expected points for next week, our model is not entirely accurate, as players are only awarded integer points and not decimals. But this total of 70.8 still gives us a high estimate with a relatively low margin of error. While this combination of players can differ from week to week, along with unexpected performances from other players not being factored in, which can change these expected points, at this point in the season for this given game week, which was last weekend, this grouping of players is expected to provide the best chance at beating your friends and winning your fantasy league this week. Thank you all for watching and have a great day.